This time I'm going to try a motion problem. This is from the 2013 AP exam. We have a particle moving in a straight line for times between 0 and 5. The velocity is given by the equation shown. They also give us an initial position. It is known that the position is 10 at time 0, and so I'm going to box that in. Okay. Part A asks me to find all values of t in the interval for which the speed of the particle is 2. Well, remember that speed is the absolute value of velocity. So I'm going to, I'm given a velocity function here. So speed is equal to the absolute value of velocity, and I want the speed to be 2 in this particular case. This is on the calculator section of the exam, so I should be able to set the velocity equation equal to the value of 2. So I can set it equal to 2, but I'm going to use the 0 function on my calculator to solve this, and so I need this equal to 0. So I'm going to add 2 to both sides to get this equal to 0, and we'll end up with 0 over on this side of the equation. Actually, the 2 and the negative 2 cancel, so I'm just setting that part in parentheses minus the t cubed equal to 0. At this point, I can go to the graphing calculator and enter this in. And so I've got my function here. I'm going to go to the y equals button, and I'm going to clear out what I currently have in there. And I'm going to put in quantity t squared so t squared plus 3t is 3t raised to the 6/5 power. I'm going to put 6/5 in parentheses there, and then I'm going to subtract t cubed. And I'm going to go to the calculate button here. So hit second trace, the calc button under the screen. And I'm going to go to the 0 function. It wouldn't be terrible to check your window first. My window here is, might expand the x value a little bit. I'm going to have the x go from -10. See, what's the interval they give me here? Actually, the interval is from 0 to 5, so really I don't need my window to go any farther up than 5, so I'll have it go from 0 to 5. The y values, as long as there's something reasonable, they look fine. I'll go with that. So I'm going to hit second trace. I'll choose number 2 there, the 0 option. And we just need to find out where between 0 and 5 this crosses the axis. We can see it come down there. And so I'm going to be asked to pick a point to the left of the graph. Let's see, right now my cursor is off the screen if you look at the y value there, so I'm scrolling to the right, and now I've got a cursor on the screen. I'll click to the left of the 0 of the function, and I'll click to the right, hit enter on guess, and it tells me here that that is approximately 3.473. Remember, in AP you went around to 3 or more decimal places, so my t value there is approximately 3.473, and they didn't give me units for time, so it should be done at that point. Part B asks me, go back and look, Part B asks me to write an expression involving an integral that gives the position s of t. Notice they said an expression, so I'm going to have an input of t, which means basically I'm going to have a t variable here. Remember that velocity is the derivative of the position function, position over time. So the antiderivative of velocity will give me position. So I'm going to take an integral here. One of the things to remember when you take an integral is that you should have an initial value here. S of 0 is equal to 10, and that's going to be key here. So I have an initial value. They want me to write an expression here for s of t. So I'm going to say that s of t is equal to my initial value of 10 plus the integral of my rate. Sometimes this is referred to as an accumulating function. If I make the integral of the velocity, it will add up all of the change in position that's taken place over the time interval that I'm looking at. So the velocity here, I could just write v of t, or I can write the actual equation. Probably a little bit more readable if I had just written v of t, but anyway, I have that. This is all going to be in terms of t, and they want me to write an equation that gives the position s of t. So that means my variable is going to be t. My integral bounds are going to start at 0, because that's where my initial value was, and it's going to go to whatever time that I want to use. They told me to call that t as my input. It's s of t, so I'm going to make that a t. Now, a subtle note here, but this is technically important. The bounds are the input, okay? I'm not inputting, you know, if I want to find the distance after 5 units of time, I'm not going to fill in 5 for this. That's part of the integral. This is your variable input. If they told me to write s of x, I would have made that an x. They said s of t, so I made it a t. I'm really supposed to use different variables for the actual integral itself, because again, the input for the function is not that value. So I'm going to have an integral go from 0 to t, because that's what they told me the input to be, and I'm going to change this to -2 plus, I'm going to just use x squared plus 3x to the 6/5 power minus x cubed dx. And again, the whole idea being that the integral is not what I'm inputting values in for. I'm inputting values for the bound. So if I want s of 5, I put in 5 for t. I'll take an integral from 0 to 5. If I want s of 10, I put the value in of 10 for t, and so on. So in this case, they want me to find the position of the particle at time t equals 5. So s of 5, basically just fill in 5 there. It's going to be 10 plus the integral from 0 to 5 of my function. And anyway, I'll go ahead and type that into my calculator and take care of that. So I'll do 10 plus the integral, that's the Math 9 button. The integral from 0 to 5 of, and then my equation is -2 plus quantity x squared plus 3x closed quantity to the 6/5 power, and again I'll put 6/5 in parentheses here to make sure that that gets included. 6/5 power, and then minus t cubed, in this case x cubed. And let's see, do I need to close out any parentheses here? I think I'm good. So in terms of x, and we get a final answer there of approximately -9.207. Again, there are no units in this particular problem, so I'm done with that part. Moving on, the question now asks me in part C to find all times t in the interval between 0 and 5 at which the particle changes direction. Justify my answer. So direction changes, I can tell if my velocity changes from positive to negative. Normally you would set your velocity equal to 0, and you would check on either side of the interval where the velocity is equal to 0. On the graphing calculator part of the test, it's not quite as necessary. I would say to at least write down that you want to make the velocity equal to 0. And then I think once I've written that down, I really should be able to go look at the calculator at the graph of the velocity function. And all I need to note is when the velocity changes signs. So anyway, that equation will help me find those actual points though. So let's see, if I go to the y equals button here, I have to be careful. That is not the original velocity function. The original velocity function had that -2 in there as well. So I need to say -2 here. And again, I may want to change the window a little bit because I'm graphing the velocity. I'm not real sure what these velocity values will be. We're still looking at the interval between 0 and 5, but I think I'm going to make my y range a little bit bigger here. Let's see if that works. Okay, we can graph this and we can see it cross the axis there. So that first place where it crosses the axis, it's equal to 0. And it looks like it crosses at 2 different places. So as long as I have my equation, as long as I'm noting to the AP grader that I'm looking for places where the velocity is 0, I should be able to use the calculator to solve that. We're looking at the 0 function again, so we're going to calc, I want 0. Again, I want to pick a point to the left, and I want to pick a point to the right. And so it looks like we got 1 point here a little bit before 1. So I'll pick a point to the left of it. I'm going to hit enter, pick a point to the right, hit enter again, hit enter on the guess, and it's about 0.536. And not only is it 0.536, but notice that the velocity changes from negative to positive. So if that doesn't happen, if it just hits 0 and then goes back below the graph, that wouldn't happen. The other place here, I want to calculate that second 0, so I'm going to pick a point to the left of that, and I'll trace over there. And once I pick that point there, I should have my second place where the velocity changes sign, which of course is going to be where this changes direction. So again, I'll hit enter on guess, and that's going to give me t is approximately 3.318. Okay, as far as your final answer goes, you really should say something like, at those 2 values of t, v changes sign. Since the velocity changes sign, the particle changes direction, something like that. I'm not going to write that up for the sake of the video. We'll look at the official answers here in a second. Part D, they ask if the particle is speeding up, is the speed increasing or is the speed decreasing? Remember, speed is always positive. So I could have a positive velocity and a positive acceleration. That would be speeding up. But a negative velocity and a negative acceleration would be taking my velocity farther from 0 as well. And so if I have positive velocity and I have positive acceleration, that's speeding up. Negative velocity and negative acceleration, that's also going to be speeding up, either one of those. Slowing down would be the case where the acceleration is in the opposite direction of the velocity. It's working against the velocity. So I should be able to check these 2 values here. I can find v of, let's see, we're looking at time t equals 4 this time, so I can look for v of 4. I could run that on the calculator. I've previously written that down. It's negative 11.476 to 3 decimal places. And then the acceleration is the derivative of the velocity, and I can find that at 4. Again, you should be able to type that straight into your calculator. Don't try to do that by hand. And that's about negative 22.295. The point is we have a negative velocity, we have a negative acceleration that is speeding up, or you could say that the speed is increasing. Okay, so we can take a look at the solutions here. Let's see, to the first part, pick up 2 points for setting the absolute value of v equal to 2. So just writing that down, even if you can't solve it, gets you 2 points. You can see our integrals there, including the integral function. You can see that they did change the variable there. So t is the input, but they changed x, the integral variable, to be something else. Down here in part C, we've got the places where v changes signs. And note that they said that v equals 0, and in fact, notice over here, you have to consider that v is equal to 0 to get any kind of credit for that. So just merely looking at your graph is not going to be enough. You've got to at least say you're looking for places where v is 0, although they don't have to see the work when you solve that. And then the last part there, you can see negative velocity, negative acceleration, or negative derivative of velocity. And so speed is increasing because velocity and acceleration have the same sign. This is the motion problem from the 2016 AP exam. You can see we've got a particle moving along the x-axis. The velocity is given by the function given. It's got a sign in it. Notice that they give you an initial position. And anytime you're given a velocity function and you're given an initial position, probably suggests there's going to be an integral involved. So mark that. Don't lose that. Very easy to forget it. Anyway, time equals 4 is the particle speeding up or slowing down. Remember, if a particle is speeding up, that means either the velocity is positive and the acceleration, which is the change in the velocity, is also positive, or it means the velocity is going in the negative direction and the acceleration is also negative. That's speeding up. So we want to check the sign of the velocity and the acceleration at 4. So I want to find v of 4 here. get that answer. I want to find the acceleration at 4. Acceleration, of course, is the derivative of v, so I'm going to find that. And I can go to the calculator pretty quickly and find these values, hopefully. Let's see what we've got going on here. The function is 1 plus 2 sine of the quantity x squared over 2. And wait, I don't want x squared though. I want this at 4. So 4 squared over 2, or I guess 16 over 2. And we get an answer here that's about 2.9787, so on. That's positive velocity. That's the important thing. We can find the derivative here. We want to find the derivative of that function, so I can go to Math 8 on my graphing calculator. Derivative with respect to x of the same function, 1 plus 2 sine of the quantity x squared over 2. Close my quantity there. This could be at x equals 4. And we can see there that I get a negative. It's about negative 1.164. So we have a positive velocity here. We have a negative acceleration. The acceleration is opposing the velocity. That means it is slowing down because the velocity and acceleration have opposite signs. All right, that's part A. Moving on to part B, what do we have here? It says, find all times in the interval between 0 and 3 when the particle changes direction. Justify your answer. Well, again, a particle changes direction when the velocity changes sign. It might potentially change sign where the velocity is 0. It's a good idea from a work showing standpoint to show that you want to set the velocity equal to 0. Again, probably not when you're going to solve by hand. This is the calculator part of the test. So you should just be able to go to your calculator, use the 0 function there, and again, we're going to type that same function in there, 1 plus 2 sine of x squared over 2. And we want the places where the velocity is 0. Again, I'm going to check my window here. My window goes from 0 to 5 right now. I'm going to change it to go from 0 to 3 because that was the interval they gave me. And my y values look reasonable. So I'll hit second and calc, or second trace, and I'll choose the 0 option here. Let's see where the velocity is 0. And so there's my velocity function there. And looks like it changes from positive to negative way over at the edge of the window there. So I'll go trace that. They want a left bound, so I'll click to the left of it. Looks like it's going to be close to 3 where that happens. I'll click to the left, and I'll click on a point to the right of that 0. And it looks like that happens at about 2.707. So I can say something like at t equals 2.707, the velocity changes from positive to negative, so the particle changes directions. Changes direction. All right. What do we have for part C? It says, find the position of the particle at time t equals 0. Well, remember that the derivative of position over time is velocity, so I want to take the integral of velocity. But remember that I may have a constant value as well. If you look up here, there's that initial value. The x position is 2 at t equals 4, so it's not at t equals 0, but at t equals 4, my position is 2. So x of t is equal to 2 is my initial position, plus, and I want an integral from the initial position they gave me is at t equals 4. I'm going to accumulate change that's happened because of the velocity. but we're starting at t equals 4, and we're going back to t equals 0. Now, if you're doing this by hand, you've got a higher number here and you've got a lower number there. You may want to flip-flop those two bounds if you're doing it by hand. And if you flip-flop the two bounds, you need to change the sign of the integral. My calculator is going to do this for me, so I would just go ahead and type that into the calculator. And anyway, if you do that on the calculator, you're going to get approximately 3.815 is going to be the position. And again, they didn't give us units, so we don't have to worry about that. And finally, part D. Part D says find the total distance the particle travels from t equals 0 to t equals 3. Notice that's distance, not displacement. Okay, so I need positive velocities. So I want to accumulate the change in the positive values of the velocity that takes place over that time interval from 0 to 3. And again, I can type that into my calculator. Remember the absolute value function there, and you'll get 5.301. That's the final distance. If they ask me for displacement, I would just take the integral of the velocity. That would include positive and negative signs. And it's even possible that we would have offsetting positive and negative velocities. You could even have a displacement that's 0, even if it moves somewhere, but it returns. So be careful. You don't just want to take the positive answer at the end, because if you had parts that canceled, you'll lose that aspect. So it's got to be an absolute value. If you're on a non-calculator part and you're trying to do that, you would have to figure out where the function was positive and where the function was negative by setting it equal to 0 and then testing the signs in each interval. And you'd basically have to find the positive integral part, you'd have to find the negative integral part, and you'd have to make that negative integral positive. But luckily, we're on the calculator part here, so we don't have to worry about that in this particular problem.